Imagine building a massive city without a plan. Roads overlapping, traffic chaos, duplicated buildings, and zero coordination. Sounds like a nightmare, right? Well, that's exactly what happens when you build distributed software without clear boundaries. In this video, we are diving into one of the most critical and overlooked parts of software architecture, defining distributed software boundaries. Whether you're refactoring a monolith or building your dream product from scratch, getting this right will save you years of pain. Scaling issues, technical debt, poor team productivity, you name it. I'll walk you through what makes a boundary good, what not to do. Trust me, I've seen it all. And a proven method that top teams are using to align business and tech from day one. If you're a software engineer, architect, or team lead, this is the video that could change how you think about the entire systems design. My name is Derick Chen, and this is BuildWithDC. Distributed software boundaries are the logical breakpoints in your entire software landscape where responsibilities, data, and behaviors are independent. In a correctly defined boundary, a software service is highly cohesive and allows for loose coupling with other services or modules. What's high cohesion and loose coupling? High cohesion means that everything within a boundary is related and works together closely. Loose coupling means that the services interact in a way where we can minimize dependencies and ripple effects. Well-defined services can be developed, deployed, and scaled independently. If you're building a product or refactoring a monolithic application, it is absolutely critical that you get it right early. You must do this correctly as early in the process as possible. See, poor software boundaries are like poor city planning. There are huge cities in the world today where the city is spending millions trying to resolve traffic jam problems and duplication of services, but it takes so much time, effort, and capital to make any significant improvements at all. When you're building distributed software based on poor boundaries, this has a long-term impact on scalability, maintainability, and team productivity. It encourages an exponential growth of technical debt. Complex inter-service communication, difficult to build on new features, data duplication and inconsistency, and of course, costly infrastructure. Just to name a few of the challenges down the road waiting for you. This is a very common problem when I visit large organizations today, and it is one of the root causes of why microservice architectures fail. Let's review the most common methods of how software boundaries are drawn in large organizations. Firstly, you have the org-based boundaries. The software architecture layout mirrors the team structure in a division or a department. This is Conway's law in action, where team structure becomes the system structure. This is typically not ideal because we should structure teams around software architecture, not the other way around. Not to mention that HR typically does not structure teams to optimize for software delivery as much as they want to. And secondly, lines of business, such as departments like sales, marketing, or customer support. This is problematic because this is way too broad and functionalities often overlap. If there is a set of functionalities that both sales and marketing heavily rely on, then which one of them should own and deliver it? Or do we just replicate that in both services? And 3, companies decide service boundaries based on the existing data structure. This is typical when you are modernizing a monolithic application. You already have a huge relational database with different tables, over 100 columns each. Naturally, you want to minimize changes on the data structure. It's a huge effort. But the data exerts a gravity on how we design and implement software applications. If your data is centralized and you do not want to change that, you will not be able to realize the benefits of decentralized systems. Now, what's a better way then to define the service boundaries? The above methods are not entirely wrong, but they are too naive and single-dimensional to capture the complexities of software engineering in a distributed landscape. There's no question about a starting point. It has to be the business understanding of how you provide value to your customers. You may have PRDs and user stories, but those on their own are not informative enough. You need to understand the key workflows and processes that create user or business outcomes, both from a product and a technical point of view. That's why I always start the discovery process with a workshop called Event Storming, based on domain-driven design, to understand the responsibilities of the application and the business. I've discussed more in another video here using event storming for behavior design, so remember to check it out. The benefit of this method is that it unveils the process flows, dependencies, and identifies integration points quite naturally as you practice it with a room full of both business and technical stakeholders. Typically, no single person in the room has a full understanding of everything that happens, so this is a very good exercise to align everyone on the language and processes of this software system. At the end of event storming, you will derive bounded context that could become a candidate service in a microservice architecture. From there, then model the integration patterns and the business concepts. There are a few things you need to be comfortable with when you switch to a distributed architecture. The first is that you need to distribute the modeling of concepts in your product. Each service must be self-contained, and you must minimize data duplication. That means you may model the same concept differently in each service, with a good reason. For example, in an e-commerce scenario, let's say we have catalog, review, and warehouse services. Each of these services need to refer to the concept of product, but due to the differing responsibilities, they all have a different view of what a product is. In the catalog service, attributes such as title, description, and images must be implemented for the web pages to be rendered to the users. While in the review service, you just need to model the star ratings and user feedback. Then in the warehouse service, you'll be more concerned about the aisle and shelf location, weight and dimension of the product, and etc. All the different product classes will be linked via a UID. They're all trying to model the same idea, but only in ways that matter to the responsibilities of that particular service. That means you may have some transactions that require functionalities and data from different services. This is when tactical integration of different services makes a difference. You have to be very intentional about integration with the aim to preserve the autonomy of each service. Avoid APIs that force cross-service logic and choose asynchronous communication methods such as events where possible. If you must implement synchronous workflows, explore orchestration services. As you dive deeper, you will encounter more specific and technical challenges in the distributed system. While I won't go into each of the areas specifically, I will give you some ideas here for further research. As a software engineer, you must explore distributed design patterns for solutions without reinventing the wheel yourself every time. If you're looking to improve data consistency, look into the Saga pattern. For operations that involve multiple independent services, check out orchestration and compensation transactions. When you need to optimize for query time, look into CQRS. And for fault tolerance, there's also a circuit breaker pattern. These patterns will also help you retain the ideal software boundaries without sacrificing on the user experience. With good software boundaries, you have the foundation for faster delivery, better scaling, and clearer ownership. I promise that the time spent finding the ideal software boundary is a worthy investment for years down the road. Don't rush into microservices without modeling the domains correctly. Once you have determined the right boundaries, explore the different levels of integration options available to preserve the highly cohesive and loosely coupled nature of services. If you want to learn how to build complex software systems faster and better, remember to hit that subscribe button. My name is Derick Chen, and see you in the next video.